Good day everyone, I am Respicio. So today I'm gonna show you the algorithm scheduling. The first come first serve, shortest job first, and the round robin. For the first come first serve scheduling algorithm, here's the breakdown code. The struct process. The code defines a struct process to represent each process with the following attributes. Name is for the name of the process. Example, P1, P2, P3. Arrival time, the arrival time of the process. Burst time is for the burst time or execution time of the process. Completion time is the completion time of the process. Turnaround time is the turnaround time of the process or the completion time minus arrival time. Waiting time is the waiting time of the process, turnaround time, and burst time. Compare arrival time function. Function is the comparison function used to sort the processes based on their arrival time. It takes two process objects as argument and returns true if the arrival time of the first process is less than the arrival time of the second process. Calculate time. The completion time, turnaround time, and waiting time for each process. It takes an array of process objects and the number of processes as argument. It initializes the current number to 0. Iterates through each process in array. If the current time is less than the arrival time of the process, update the current time to the arrival time. Calculate the completion time of the process by adding the burst time to the current time. Calculate the turnaround time of the process by subtracting the arrival time from the completion time. Calculate the waiting time of the process by subtracting the burst time from the turnaround time. And update the current time by adding the burst time. The print result function is to print the result of the simulation including the completion time, turnaround time, waiting time of each process. It takes an array of process object and the number of the process argument. Ask the user to enter the number of processes. Create an array of process object to represent the processes. Ask the user to enter the arrival time and the burst time of each process. Sort the processes based on their arrival time using the compare arrival time function. And calculate the completion time, turnaround time, and waiting time of each process. And print the result of the simulation. This is the breakdown code of scheduling algorithm of first come first serve. Calculate the completion time, turnaround time, and waiting time of each process. So, for the processes, we have 3. The P1 arrival time is 0 and the burst time is 5. The P2 arrival time is 2 and the burst time is 3. And the P3, the arrival time is 4 and the burst time is 3. Here's the result. For the shortest job first, here's the breakdown code. Struct process is to represent each process with the following attributes. The process ID is for the process ID. Arrival time is for the arrival time of the process. Burst time is for the execution time or the burst time of the process. Completion time is for the process of completion time. Turnaround time is for the process of completion time minus arrival time or the turnaround time. The waiting time is for the waiting time process or the turnaround time or the burst time. Compare function is the comparison function used to sort the processes based on the arrival time and burst time. It takes two process objects as argument and the return true if the arrival time are equal and the burst time of the first process is less than the burst time of the second process. The arrival time of the first process is less than the arrival time of second process. SJF scheduling function or the shortest job first function or scheduling is to simulate the SJF scheduling algorithm. It takes a vector of process object, an argument, and perform the following step. It sorts the processes based on their arrival time and burst time using the compare function. Initialize the current time to 0. If the current time is less than the arrival time of the next process, update the current time to the arrival time. Set the completion time of the current process by adding the burst time of the current time. Set the completion time of the current process by adding the burst time to the current time. Calculate the turnaround time and waiting time for each process. Print Gantt chart. The function is to print a Gantt chart representing the execution of each process over time. Print result is the function print the result of the simulation, including the completion time, turnaround time, and the waiting time of each processes. The main function is the entry point of the program. It asks the user to enter the processes. Create a vector of process to represent the processes. And ask the user to enter the arrival time and burst time of each process. And call the print result to function to print the result of the simulation. This code simulates the shortest job first scheduling algorithm with the print of Gantt chart to display the result of the simulation. The number of processes is 4. The arrival time and burst time of P1 is 0 and 7. The P2 arrival time and burst time is 2 and 4. The arrival time of P3 and the burst time is 4, 1. The P4 arrival time and the burst time is 5 and 4. So here's the result with the Gantt chart. This is the breakdown code. Struct process is to represent each process with following attributes. ID is for the process ID. Arrival is for the arrival time of the process. Burst is for the burst time or execution time of the process. Remaining is for the remaining time of the process. Completion is the completion time of the process. Turnaround is the turnaround time of the process. Completion time minus the arrival time. Waiting is for the waiting time of the process. Turnaround time minus burst time. The round-robin scheduling function is to simulate the round-robin scheduling algorithm. It takes a vector of process, objects, and a time quantum as an argument. The function thus initializes the current time to 0. Iterates through each process in the vector if the remaining time executed for the minimum time of the time quantum of the remaining time. If the process completes during the time quantum, its completion time is updated and its remaining time is set to 0. The current time is updated by adding the time quantum of the remaining time. Step 2 to 5 are repeated until all the processes have completed. Calculate the turnaround time and the waiting time for each process. The print result function is to print the result of the simulation, including the completion time, turnaround time, and the waiting time of each process. The main function is to the entry point of the program. It asks the user to enter the number of the processes. Create a vector of process objects to represent the processes. Ask the user to enter the arrival time and the burst time of each process. Initialize the remaining time of each process to its burst time. Ask the user to enter the time quantum. Calls the round-robin scheduling function to stimulate the round-robin scheduling algorithm. Call the print result to function to print the result of the simulation. This code simulates the round-robin scheduling algorithm. Calculate the number of processes is 4. The arrival time and burst time of P1 is 0 and 8. The arrival time of burst time of P2 is 1 and 4. The arrival time and burst time of P3 is 2 and 9. The arrival time and burst time of P4 is 3 and 5. and the quantum time is 3. So here's the result.